Today's panel, myself, I'm at UC Davis. Melody Baglione, she's from Cooper Union, and Devon Schmidt is a recent graduate from UC Davis Energy Graduate Group, and all three of us will be talking to you today. We'll give a little background on the Global Energy Managers Workshop, what the purpose is. We're going to do a short poll to figure out who exactly is in this session. Looks like about 40 people so far, probably a few more people will be joining. And then we'll just talk about some case studies in client-focused project-based learning in energy. And there'll be some from UC Davis and Cooper Union. We'll do a little bit of interactive activity to get some feedback from you guys to wrap up, and then there'll be an offline survey for you guys to complete. So, a little bit background: Sustainable Campus, Sustainable Cities is an initiative at UC Davis that I worked with other faculty, staff, and students, recognizing that so much energy and carbon footprint comes from buildings, and that UC Davis has 1,200 buildings, and that UC Davis is kind of like a city, 60,000 people. We have our own wastewater treatment plant. We have a lot of renewable energy, and we thought that we have a goal of carbon neutrality and zero net energy, and we were wondering if we could use it as a living lab and then learn from that. And so the way we're doing this, next slide, is through Sustainable Campus, Sustainable Cities initiative. Has 4 pieces to it: progress, which is real on-campus projects to lower our energy and carbon footprint; research, which is pushing that learning out to the greater academic community; education, which is getting students involved in client-focused project-based learning through energy graduate group and interdisciplinary, multidisciplinary classes; and the outreach, which is a part of this global partnership. Okay, next one. Next slide. And then Global Energy Managers Workshop in 2019 was pretty successful. We had 70 people from all over the world and a bunch of different countries. We had different focuses, but we did run a zero energy curriculum tool workshop where we actually worked with people to use design think methodology to design their own energy course at their own university. We're not going to do that today, but you could look at the session from last year. And also, UC Davis does work with other universities to do this. So if you're interested in what you see after today, please contact us. You can hit the next one. So what we're really hoping to do here is to share some stories from Cooper Union or UC Davis. Hopefully get some of these collaborations together between our institutions and your institutions, both collaborating on energy projects or carbon projects, teaching, sharing curriculum, because we're always looking for new curriculum, new ways to get students involved in energy, and really inspire more project-based learning, because I found, and I think that Melody agrees with this, that when you get students to work on real projects they care about, they just learn a lot more. So quick poll, just to figure out who's out there. The categories that we've chosen for you to respond to are educator, facilities, that would be someone on the ground working with energy management, building maintenance, anything like that. Somebody who's in the administration who might be in charge of policy planning, sustainability efforts at the university, student, or anything else other. And then you can just put that in the chat if it's something that we haven't covered here. So it's great, people are filling it out, appreciate it. Wow, this is awesome. We have a lot of people from facilities, a few educators. Looks like we got a few people from administration, a couple students in there. That's great. I'm really glad to see that there's people from facilities here, because one of our hopes is that when you see some of the success we've had, that maybe you could bring that back. So you can see that 70% of the people today are in facilities of some sort, and that what I would hope you guys would do is, if some of this looks good, potentially you could work with your own faculty and administration and others to try to make efforts like this, what we're doing now. So let's go back to our main program. I'm going to talk very briefly about the UC Davis approach to all of this, and then Devon is going to talk about specifically one course that she and I taught together. So the D-Lab stands for Development Through Dialogue, Discovery, Dissemination. It's really a client-focused project-based learning. We can hit the next slide. And some of the tenets of this are multidisciplinary teams, and I'm going to talk about needs and opportunities. Well, you need well-rounded teams to get this work done, right? We know that these energy and climate problems are inherently they take people from all different disciplines to solve. It's great for students to work with people from other disciplines. It gives them good experience. And the opportunity at UC Davis is that we have this energy graduate group, which is actually interdisciplinary. So that gives us good people to work on these teams. And traditionally, in our courses, you can see we've had people from economics, management, mechanical engineering, chemical engineering, community development. Next slide. Interdisciplinary projects, that's really talking about what do these teams work on? Well, we have these complex projects. We also have the need of students to expand their skill set. And the opportunities are the EGG curriculum is interdisciplinary, and we have faculty mentors from diverse backgrounds that can help students through this. So economic, environmental, technical, social, where are the solutions lie? They lie somewhere in this cross section. Next slide. We also emphasize learning by doing. First of all, it's fun. Students like it. When you understand how something works in reality, I think it's really easy to keep that learning. So the needs are the recruiters are asking for these kind of skills, hands-on skills. Students want relevant experience. The opportunity for us were that many energy projects are hands-on. I mean, inherently, right? You have to go into a building. You have to maybe measure things. You have to look at how people are using energy. And we have PG&E, Pacific Gas and Electric Energy Center, as a partner. So they've actually been working with us to give us tools, lend us tools, and get students in there working on things. Next slide. And the last one is client-focused projects. It's really important that you have a real person or organization that you're working for. The need where we have these real energy projects that we need to push forward. We needed to give hands-on experience for students. The opportunity is we have tons of on-campus projects, and we have relationships with faculty, staff, facility staff that can actually give us access to these buildings. Next one. And then the last one, or that I think a lot of us, especially academics, are concerned about is, can we actually publish this? You know, do we have something that we could push out there that we have enough data on? And so certainly there's a need for thesis and dissertation topics for students. Also, there's a need for some of these projects are long-term, in-depth analysis that might take 2 or 3 years. And the good thing is we have MS and PhD students. We have the access to granular data because we've taken all that data at facilities, and we actually have access to mentors in all these different disciplines to be able to get the students to be able to guide them through this process of these studies. Next one. And with that, I would like Devon to take a minute to talk about specifically the Path to Zero Energy course that she worked on when she was here. You there, Devon?
Yes. Hi, everyone. I apologize that I could not get my webcam working, so you're just going to hear my voice. But I'm Devon. Like Kurt mentioned, I'm an energy graduate group student alum, and also an alum of being a TA for the Pathways to Zero Net Energy course. What I was hoping to do in the next few slides, next slide, please, Melody, is break up the course preparation and development into its component parts so you can get a sense for how the class goes at Davis and what might be applicable or repeatable on your campus. The components can broadly be broken up into client identification, project development, student engagement, and curriculum creation. So we're going to go through each of those items. Next slide, please. So first, we're going to cover client identification. When we're seeking new clients, we generally look for the following traits. They have some facility or assets that consume energy. They have either a project idea or a clear goal in mind. This is important because it usually means that the clients will be motivated to stay involved throughout the pre-quarter and quarter period. Direct access or ability to collect the data required for the project, both before and during teaching, and then have some time to devote to students throughout the quarter. Next slide, please. So next there is selecting and prepping the projects. Projects for this course are typically one of 3 different types. There's energy management, feasibility studies, and concept development. The more concrete the project deliverable is, the more likely the project will be successful. The more open-ended, the more likely the project might encounter challenges. However, it's also a cool time. It's also a time where students can be more creative, and sometimes you get something a little unexpected. I have, oh wait, go back. I've thrown in an example of each project type. So under the energy management type, last quarter, a project that was an energy management project conducted an energy audit of the UCD Health Education Building. In this project, students were tasked with reviewing building energy consumption data, identifying issues, and developing efficiency recommendations. The results were that recommendations of supply air temp and static pressure resets, along with the corresponding energy savings estimates. The feasibility study example is a evaluation study for the potential of hydroelectric power at the UC Bodega Marine Research Facility. In this project, the client had a pet project idea for a while that some of the energy required for pumping water from the ocean up a bluff into the research facility could be recovered when water is drained back down into the ocean. So students were tasked with evaluating whether or not this project was actually a good idea. And then last, the concept development project. Last quarter, a UC Davis alum that now owns and operates a large apple and pear orchard outside of Hood River, Oregon, asked us to help him create a design for an off-grid self-sustaining homestead facility. So for this project, students reviewed energy and natural resource data and came up with a potential microgrid design plan and a project implementation plan. Next slide. So then the next task is student engagement and outreach. This is something that is really important, and I'd like to emphasize that student recruitment is essential for the success of the course, especially when the class is new and might not yet have a home as part of any degree requirements. So we spend a lot of time in the quarter before making the course description and logistic information available around campus and hopefully delivered into many students' inboxes. Next slide. And then last is curriculum development. So each class session is one of 3 types that are shown here. There's guest lectures, core content, or a lab. The core content focuses on energy management activities, project management strategies, research methods, and just direct class project working sessions. The guest lectures often have a broader perspective instead of focusing on very tangible and practical realm of facility O&M work. These sessions generally focus on addressing what is the state of sustainable development and practices today. This year, we heard from CEC Commissioner Andrew McAllister. He gave us a virtual tour of his newly finished Z&E home and discussed the life of the project from design to permitting to construction. We also had David Phillips from UCOP describe the activities and progress on the UC-wide carbon neutrality initiative. And last, we usually have a few labs and activities so that students can get some hands-on time performing energy audits, understanding energy metering in practice with some data analysis. Next slide. And then this slide just shows the overall timeline for course prep and that it is ongoing throughout the year. One thing I want to highlight here is that the one thing I want to highlight is the one thing that's missing from the slide, and that's project follow-up. So this typically falls in the space between when the quarter ends and getting started. Many of the projects that start out in the Z&E course are either handed off to someone at the Energy Conservation Office or end up getting picked back up in next year's course. So the end of the course is more often than not just the end of one milestone for a given project. So that is all I have for you today. I hope that gives you a good sense of the planning for the Pathways to Zero Net Energy course. And now I'm going to hand it over to Professor Melody Baglione to talk about her project-based course at the Cooper Union School in New York.
Thank you, Devon. So for those of you that haven't heard much about Cooper Union, I'll give you a little bit of background. We're a private school located in the East Village area of Manhattan. It was founded in 1859 by industrialist and philanthropist Peter Cooper, who invented Jell-O and also put an elevator shaft in our historic foundation building before elevators were actually invented. It was tuition free for 155 years, and after charging tuition for a few years, there was some movements and people got together, and now there's a 10-year plan to return to free. And this talk is going to be about how in 2009 we moved into a LEED Platinum certified building, which you can see here, and how we engage students in real-world project-based learning with campus facilities and energy partners. So again, I'm a professor in mechanical engineering, and our students learn and take courses in control systems, mechanics, heat transfer, fluids, thermodynamics, but many of them never actually physically see the hardware that they learn about and write equations for. So a goal for me was that students need to see the real world application of the theory they learn. For example, they see thermodynamic refrigeration cycle, but they've never actually seen a compressor or an evaporator and know what that physically looks like. So when we moved into our new academic building at 41 Cooper Square, which was LEED Platinum certified in 2009 and has many state-of-the-art features, it was an opportunity to use these systems, building automation system, all the MEP system, to facilitate real-world hands-on project learning. So in 2012, I was awarded a National Science Foundation Transforming Undergraduate Education in STEM grant, a TWOS grant, to leverage the building as a learning laboratory and to develop new hands-on process control lab experiments. Here you can see some pictures of some of the elements of the new hands-on components that are being integrated into the curriculum. So first off, the core of the project was to create a new required process control lab course that revolves around a building systems theme. And in this course, students start off on benchtop rigs with actual shell and tube heat exchangers, radiator, some heating elements and sensors, and a liquid level flow experimental rig. And they do actual liquid level flow temperature control experiments. Then a content website was developed in which students can learn about background materials related to all the different systems in the building. It's divided by central plant, some of the zones such as radiant heating, some of the special features such as cogen and rainwater harvesting, for example. And then students developed a real-time interface so that you could see real-time energy and historical building performance. Then students were taken on actual building tours and to the mechanical rooms. Here you can see my graduate student in the chiller plant room, and then students were shown the building automation system and data and actual classrooms that they've been in historically. And then they're given a writing assignment to sort of synthesize what they've learned in the lab and what they've seen and how it relates and what are the what are the controller inputs, what's the process variables, and then how what type of building features are there to save energy, and how those features save energy. And then they go back to the lab and learn about the tuning methods that they've learned about in the building and implement them. But in the process of learning about the building in order to teach how the building worked, we also learned how complex it is. There's many different zones. There's laboratories that have fume hoods that were often left open. There's exhaust fans. And, in some ways, many of the labs, for example, I'm a professor and I have a lab, but I'm a mechanical engineering professor, so there are no chemicals in my lab. But the architects designed my labs to have excessive ventilation as opposed to the chemical or the wet labs where they're actually a need for extra ventilation. So that's something we learned that was probably causing the building to consume too much energy than it really needed to. We have radiant panels with three-way valves, and this sort of using the air side before we use the radiant panels was one of the things that we found, and that wasn't necessarily energy efficient. There's radiant flooring, and a cascading. All the classrooms and offices are 100% dedicated outside air units, but there's a cascading atrium that takes air from the atrium. It takes corridor air and uses it in as return air for the air handlers that provide air to the laboratories. And that had a complicated control system because there's 2 plenums that were shared, or 2 air handlers that shared 1 plenum, and that made the control system really complicated. Again, different terminal end units and different controls, and the building management system didn't necessarily have all the control parameters displayed in a clear way for the operator. So they didn't, for example, in one instance, they didn't know that the output, it was presented as a percent valve position or damper position, but we actually found out by digging into the manuals that it was actually a state variable that told you whether or not the controller could only output whether or not the damper was opening or closing, or closed or open all the way and not moving. So the operators were misinterpreting the information from the building management system. So in essence, the point I'm trying to get at, there were, in the process of learning about the building, we also learned about its complexity and that it was also ripe for retuning. Many actuators were failing, probably, too many actuators in too many zones, for example. We had a cogeneration system that was plagued with problems. The absorber constantly failed and didn't work properly. We were all these different systems in the building, and from the time we moved into the building, the first 5 years, which I've read is very typical for a LEED Platinum building, the energy actually increased. So the moral of this is that we found there was a need to apply fundamentals and a systematic approach to achieve and maintain efficient operations. And as many of you that are facilities energy managers know, that the staff on the ground are often just answering calls, and if someone's complaining that a room's too hot or too cold, and they're just attacking and approaching those fires, and then when they finally have a chance to figure out what to do, they're just overwhelmed by these complex systems and where to focus their efforts and energy. And that's where I think having students looking at the data and doing project-based learning, such as Devon mentioned, static pressure resets and being able to look at the damper positions. So they're simultaneously learning, but also really making a difference in their environment and helping our staff. So that's where we started to engage the students that took the required course, learned about what I was doing, and a handful of them would go on to engage further, such as student interns in their capstone senior design projects and master's research. And we developed a new energy efficient building systems course that's co-taught by an energy consultant. And you can see students actually out in the field getting data, developing dashboards for the staff so they could see the problems, and making improvements. So students are involved in baselining building energy consumption, tracing energy use using a Sankey diagram, and tracking our progress towards our 40 by 30 target, which you can see here, our projection to meet our 40 by 30. Creating data historians, energy dashboards, and reporting tools, analyzing and optimizing the building systems and controls, and contributing to building science research. So if you want to learn more about these projects, I'll share a link to my website at the end of this, which has detail about some of these projects. But a goal was that our students would enter the workforce with industry relevant skills, because they're actually doing work that was industry relevant on our building. So these are just some example projects, including, looking at our double skin facade and how much energy it actually saves by doing computational fluid dynamics modeling, also related to being able to change the air change rates in the lab to exhaust an acetone, hypothetical acetone spill, to see if we could reduce the air changes. And now we're actually going to take that a step further with COVID to try to model, if you have a masked flow or unmasked particle, or someone, whether or not if we change the air change rates, we'll be able to. I know ASHRAE is put out some standards, but there isn't a lot of science as to the airflow of those potentially infectious veterans. We just presented a paper at the ASHRAE conference on chiller plant optimization and condenser water reset, and that control strategy that the students did in the energy efficient building systems course was actually implemented in our building management system. So I can go on and on about projects, but I want to also save some time for us to start doing some things that are interactive. But we got some funding, through not only National Science Foundation, but NYSERDA, which is the New York State Energy Research and Development Authority. And through the funding from NYSERDA, it supported us hiring Schmidt Engineering as an energy consultant to help us develop a roadmap to achieve our 40% carbon reduction by 2030 target. It also helped us to sort of divorce the data analysis from the building management system onto a separate OSI Pi server and start doing energy and analytics, and the students are building dashboards to be able to alert the staff to problems, because as the data was being presented in the building management system, really didn't highlight areas of concern in an intuitive way. And we also have funding to develop site-specific training for our facility staff and curriculum, and to implement, best practices and optimization, in addition to this new energy efficient building systems course that's being co-taught. And the outcome is this: since 2014, when we really started engaging in these projects, our carbon has gone down. And we still have a long way to go to our 40% reduction target, but we've made progress and we're continuing to make progress. In summary, since 2014, we've had 2,500 tons of CO2 saved. We saved $1.4 million in energy. We have 3 buildings on our campus, so that includes all 3 buildings. 10 facility staff have been trained. We've had publications in ASHRAE and ASME and others, master's thesis related to the building, poster presentations at 10 different conferences, capstone senior design projects. And this is the website hits as of a while ago. I haven't updated it recently. But I think in some ways that's how Kurt found me, through one of my websites talking about radiant panels. So probably wouldn't be here today if it weren't for some of the information there. But Kurt asked me to end this presentation with sort of the biggest challenges and lessons learned in engaging stakeholders, and I kind of have a lot of them here because I figure there are a lot of different people attending this presentation. But in terms of the collaboration between faculty and the staff, there's really a taking time to build trust and appreciate each other and what they bring to the table, and finding time to meet with the stakeholders is essential, because they're again always busy fighting, answering phone calls and complaints, and I think it helps them, for us to focus them on other maybe things that people don't see that are wrong, but can be fixed when they have people actually looking at the building management system. And I think that helps them to align the projects with the current operational needs. So if we're having them focus on something that is a less concern to them, then they're less likely to be engaged. That the training, and this is true both for the facility staff, but also for the students, that maybe you start off general, but ultimately needs to be site specific. I think even the students in the courses get more out of it if they can see how what you're showing them is related to an actual building, and even better if it's in a building that they're familiar with and go to every day, such as a campus building. And to offer different modalities, especially in this online environment, to accommodate different learning styles. There are different facilities staff at Cooper that some of them like web-based training, but others don't. Some like more field training, and so being able to accommodate different learning styles so that we can get important information across to them. And that recommendations need to be supported with evidence. Oftentimes I'll have conversations with our chief engineer about certain things that he's doing, and it doesn't hold as much weight if I just say, well, that's the way you're supposed to do it. It helps to show, well, in Saturday morning, if you let me run it this way and show you what the kW per ton is if we do it this way, supporting it with evidence really helps to get your recommendations across. knowledge transfer is critical, especially when you're a professor and you constantly have students graduating, and that's a great thing. That's what we're here for. They're going off and doing wonderful things in other places, but it makes my job difficult when I'm constantly in this, training new students. So, and also for the facility staff, I mean, they just had binders and operating manuals all over the place in someone's email, so, really trying to set up a central and organized repository and ability to knowledge transfer and onboard people, and to vertically integrate teams as student teams, enlist senior students to onboard new students that are interested in this work. That's another lesson learned, and learn from other institutions. So here in New York State, we have the Rev Campus Challenge that has annual meetings and workshops, and the New York City Carbon Challenge, which has quarterly meetings. But I really see that as an opportunity to meet other facilities, management, staff, energy managers, and learn what they're doing, learn vendors that they've worked with and had success with, learned about programs and funding through the government, and acuity projects, things like that, and how it's working out, how to upgrade our BMS when we eventually have to do that, and how that's going. So I think at this point, I'm going to save us some time. We wish we could interact with you in a way where we could see you, but unfortunately this platform doesn't allow that. So I see that there are some people that do want to take a virtual field trip. I think we all would like to take field trips right now, but certainly a lot of information on my website about the building. Some of it, we developed years ago, and we've learned even more. It needs to be updated, but that's a good starting place, but I'm happy to start more conversations with more people. So, yep. Kurt.
We're going to do this interaction session in just a minute, but I appreciate that, Melody. That's awesome. Sounds like we've had some similar experiences with buildings that have run away and then trying to figure out what's going on with them, and nobody really knows. And also, with us, getting the students to be really part of that thing. So, and I think with this online environment, we actually ran our course online, which, the first time ever, it was a hands-on course where no one could touch their hand to anything, right? I think we had some, students actually came away with it okay, but it took a lot of effort, and part of that was just making sure that the projects lended themselves, right? So you can actually do a pretty good feasibility study without actually going into a building if you have people in there who can get the data, or if you have the data. So there are ways to do it virtually. I think it's definitely trickier, and you have to set it up right. So you want to try to launch us on this next journey, Melody?
Yeah, sure. So we were hoping that all of you could sort of talk about what needs you've identified. And we keep saying chat, but I think it's really just the only way to really communicate to us, and we see your questions. So you can, any needs that you've identified at your institution in your role, and maybe we'll kind of come up with some common themes and aggregate them, and then possibly some opportunities, or maybe, as someone in your different role, projects that you wish you could work on, but you just, maybe it'd be great to have students work on these projects, for example.
Yeah. So if you're able to put them in the questions box, that would be great. We can take a look at them and review them.
So I'm hearing honest assessment. So is it, I'm assuming that means like an honest assessment of the building or campus and how things are running. Yeah. So
oh, somebody asked to share the toolkit link. I thought it was in the presentation, but I will try to put it in the chat.
So I see we have 61 people, and the majority, like 70%, are facilities staff, energy managers. So there's got to be some like itching projects and things.
Somebody put here retro commissioning, I think, right?
Yeah.
I saw that. I think just with a couple of explanation points, because I think that's kind of what we've seen here too, is we have these buildings that aren't very old, and they already need to be kind of overdone.
I'm presenting, but I'm gonna stop only that I can move out of presentation mode and actually add some.
Okay, great.
My slides.
I'm going to look for this link. Are you keeping track of these questions also?
Yeah.
I'm gonna find this toolkit link for you guys.
Okay, so that way you guys can see, and I'm just going to kind of summarize, some of the needs is retro commissioning. And New York actually passed a law that all buildings have to have a retro commissioning and energy audit every 10 years based on their building block number. So I've been through that process, but it really should be ongoing, right? Retro commissioning. Honest assessments. I can appreciate what that is. I mean, I think sometimes people don't want to admit things aren't working. And because, from occupancy perspective, a lot of things, if you just come into the building, you know that the temperature is okay and everything's working, so it must be fine, it must be running smoothly, but that's not necessarily the case behind the scene. That's, it never likes the way you spell retro commissioning. Staff development, so again, so for me, I find, there's kind of a different audience, but you can sort of utilize, teaching a course for students, but then also some of the content can also be repurposed for the facility staff.
Can you hit on the, I think I don't have, I'm not able to do the.
To see these questions, you need to click on
I can see them, I just can't answer them. I can't answer them.
I don't know.
Okay, that's all right. Keep going. I'm going to put that in the chat. Somebody asked about the toolkit. I'm going to stick it in the chat.
Yeah. And maybe Kurt, like in addition,
if you type on the question, you should be able to type an answer below. You have to click on each individual question though.
Okay, great. Keep going.
Yep.
What else we got there? Somebody said, thank you. I hope you're not leaving yet.
There was one comment that was the value of doing work in-house rather than outsourcing.
Yeah, I always wish Cooper would hire more people to do more of our work in-house, but the budget just isn't there. And that's why, the students are really great opportunities, but still, yeah.
Do you have any tips for determining building occupancy on a given day? Devon might know more about this. One is Wi-Fi data. It's pretty good. We also have occupancy sensors, which are not as good, CO2 sensors. Devon, is there anything I missed?
We have key card swipes.
Oh, that's a good one. But a lot of Davis buildings don't have key card entry. So yeah, like Kurt mentioned, Wi-Fi data. So there's a bunch of access ports around campus, and we've been getting the data for how many devices are connected to those points, and so then you can get kind of a proxy for how many people are in a particular building. And that has been really pretty reliable. The only thing it's bad at is figuring out if there are 0 people in the building or not.
And that's kind of what the piece of research that I was pointing out to that called Putting Buildings to Sleep that we're going to have be published recently. Looking at inferring vacancy, right? Occupancy is one thing and vacancy is another, and how confident can you be that there's nobody in the building? So 2 things you want to know is how many people, and then you might also want to know if there's nobody in the building. And so sometimes there's different data streams you can get, like we talked about, and then you can take some fusion of the sensors and try to get better results from fusing the data from the different sensors.
So we talked about a little bit about the needs, and I'm happy to answer. There's some specific questions about what work, if there's time, about what work we're doing at Cooper Union, or I'm happy to answer some of these questions offline, because especially with related to optimal air changes, we're doing some things along those lines, and I've talked to other institutions in New York City. But do we want to talk about the opportunities that maybe that as well?
Yeah. So it's great talk. Yeah. So because I think that I'm an opportunist. I don't know if Melody is also. is a lot of it is you see these synergies between the needs that you have and like at Davis, I think one of our opportunities was a good working relationship between faculty and staff and administration. So that was that was something that we had. So anything that you guys see there is kind of like an opportunity, or a terrible building that needs to be fixed. I don't know what they are.
Prioritizing.
Hopefully,
Prioritizing.
priority. There you go.
I just saw Josh's comment that he's going to talk about Wi-Fi data in the next session. So people that are interested in learning more about inferring building occupancy with Wi-Fi data, maybe check that one out.
And I just saw somebody mention that water is another place. How much water use is another way to get data about who's in the building, how many people are in the building.
Another kind of obvious one is CO2 sensors, but those are kind of rarely in the building.
We have them in our building, but they're not they're not used for much. They're just monitoring.
Melody, there's a question about what is the legislation that requires retro commissioning every 10 years in New York?
Yeah, it's local law 97. Local law 90. Oh, I didn't realize there were more questions. I didn't scroll my mouse down. I thought I had them all.
I'm just rolling through.
I thought I was summarizing them. Local law, Cooper Union, I'm sorry, New York City has passed a number of legislation. So they're always like LL because it's local law through City Council. So there's local law 97 is every 10 years retro commissioning and energy. And you have to do a level 3 energy audit every 10 years. So we're due, our lead platinum building is due in 2 years. And our other 2 buildings, our historic landmark building built in 1859 is due 2 years after that. And then at that same year, because it's based on building block number, our resident hall is due. We're not as big of a campus as UC Davis, so but we are in a city. Even though our campus isn't a city. So
we're
stakeholders, yes.
And I also saw somebody, even though it's not all needs and opportunities, needs is looking at turning buildings down for COVID. And I told that person that they should listen to the next session. Josh Morjohn is going to talk a bit there. And you can also contact him or myself directly, because that's kind of an area of research that we're working pretty strongly on right now. And it's not just an area of research, it's an applied area, because we're really trying to save energy by turning these buildings down.
I understand how to turn. So and the COVID question is really interesting, and it's a problem. I'm going to say it's a problem because I've watched many ASHRAE webinars, and the recommendation is right 2 or 3 air changes per hour. And some buildings don't have that capability, but our lab building does. 3 air changes per hour and a 3-hour pre and post flush. But like our building, there's like a pretty stringent way, like you can come, but you have to have a COVID test every month. You have to have an app, and you have to have dean approval to come to campus. And so there has to be a reason. You're not just coming to campus, like you have to have a reason. So the number of people here it's like there are people here, but it's a ghost town. So it's like the trade-off is, would we want to increase ventilation because that's what the recommendations are for COVID, but there's really no one here. But there are a few people here. So how do I keep those people safe? It's really a challenge, and we're going through room by room what the air changes are for occupied and unoccupied, and just kind of making the best decisions that kind of balance that trade-off.
And I think one of the big sinks that we saw in phantom loads was from the AV equipment, especially like when we're looking at the campus during vacation times. It's unbelievable how much energy some of this is like for classrooms where you don't have that much any energy load otherwise. But the problem is you turn these systems off, and then the professor comes in the morning, can't turn anything on. So yeah. We actually went through and we actually tried to turn the systems off and see what would happen.
I'm almost embarrassed to show this to you, but this is our last 24 hours. Like we don't turn things off at night at all.
Wow.
You know, you guys, I remember the presentation earlier this morning where you guys were like 40% is what we are when it's unoccupied, and we want to get it lower. And I'm just like, yeah.
It's probably
and part of that, yeah. So there's very little turning things off at night in our building, and it's difficult to get people to understand.
We have a much different climate than you have too. We're heating and cooling buildings every single, maybe you are too, but we're heating and buildings almost every single day of every single all of the year.
But that dashboard was created by students, by the way. So yeah. So did anybody have like great ideas of how they, oh, wouldn't it be great if I could work with facilities as an educator, or I'm at a school and I have this department and faculty that does this, and
Yeah.
Or
remember, one of the goals of this session was to inspire more project-based learning.
I've heard there's one about comparing. I think that's an opportunity, comparing data trends to network use. I mean, really, that's another thing is we really, facilities and IT are kind of separate, and it's like, I don't know if your institution is the same way, but really trying to use the information that they have more. I'm gonna just cut and paste some of these things. Partnering with labs on greenhouse.
Partnering with labs on green labs, making good progress. That's great.
And there's a term out there that I'm not familiar with. So RCX, retro commissioning. What is MBCX?
It's another. It's like a efficiency incentive program in California. I forget what it stands for.
Okay.
And I'm gonna.
But yeah, I think just opportunities are potential local policies.
Monitoring, yeah. New York City has, or New York State, I'm sorry, has money that they do cost sharing for you. It's called RTEM, Real-Time Energy Management. So, one of our buildings is, we have interval data, and we're actually metered and actually charged on interval. But that data that you just saw was that interval data. But there's programs in New York State to fund cost share programs to add interval meters so that you can monitor your usage.
We're going to get cut off in just a minute here, but I did want to point people. I just in the chat I put the UC Davis CEED, which is the education dashboard, and you can go on that and you can look at all of our different buildings, and especially you can look at the labs, because there's some question about labs, and you can go and look at the EUI of each building and some details on the energy use. So feel free to go to that and take a look.
Yeah, and New York City has started, you have to do energy scores and you have to post them on your buildings. It started with restaurants and now they're doing it for buildings, and part of your energy grades from the portfolio manager. We had to submit that data every year, and now they're doing grades. But here's our contact information. I'm happy to share more information about the projects that we've done, and thank you for your time and your attention.
Yep, and I appreciate, hey Melody, thanks for coming all the way out to California to do this. And Devon, thanks.
I will make it out one day.
And I'm from New York. Okay, and please give us a shout out if you guys are interested in any of the stuff that we talked about. I'm totally happy to work with any of you guys to implement more of this kind of projects and curriculum.